Yeah, my name is Parker Ence, CEO of Veraset. And as I was kind of thinking about this session today, I was walking through my house, getting ready to go, and noticed all around my house there were like little toys and like some little pieces of garbage and food occasionally. And this was like a physical trail that was left behind by my young 2.5-year-old daughter. And so it's kind of this like breadcrumb trail that is very, very clearly shows where my daughter had traveled in the house. And so in a very similar fashion, we all leave a breadcrumb trail, a digital breadcrumb trail with our smartphones, as you all well know. And so Veraset is in the business of gathering that anonymized location data from mobile devices and making it accessible to geospatial data scientists and product leaders and analysts. And so when we kind of look at across all of our teams that we work with, that we provide data to, we notice that this data is used in a lot of different industry verticals, everything from telco to real estate, market research, hedge funds, advertising. And this data is available in varying levels of aggregation. So on the one hand, it's as raw as a simple device ID, timestamp, and latitude longitude reading. On the other hand, it's completely aggregated and developed into built out insights and visualizations and models. And so what we find, what's common amongst our customers, really three things. The first is they are geospatial data science product or analyst teams. They want to build proprietary models themselves. So they want access to the raw data, and they want to build the models themselves. And then the third is that they want to enrich the data that they already have with external mobility data. I spent a brief time working at Google in Google Cloud, and I was part of a team that was basically pre-training machine learning models for the purpose of matching job seekers with employers. And I think that's when I realized that no matter how good the machine learning model is, no matter how good the algorithm is, it's all about the data. So if you have the right data, then those models can really come to life. And what we found is that most organizations don't have all of the data that they need. And so specifically within retail, we see three common themes when it comes to research objectives using this mobility data. The first is just gaining a deeper understanding of current and prospective customers. And that can look like origin destination pairing, or understanding the relationship between home, work, and local retail or commercial sites. That can be understanding the commercial journey from morning until night. That can be more core advertising use cases around building proprietary audiences based on location context. That can be measuring offline impact of online or mobile ad efforts. We see our customers joining location data with transaction data and demographic data, typically by census block group. And then the third type of project we see is looking at a site. So looking at how is this site performing? Can we predict how this site will perform in the future? Where do I put a new site? How do I prioritize shutting down a site if I need to shut down a site? And then on the investing side, how do I drive alpha with unique performance insights? So those are some of the research questions that we see our customers tackling. And the approach that they use, I think, is summed up pretty well by this from McKinsey. So it goes with any retail geospatial analytics initiative, the starting point is data. A retailer seeking to optimize its omnichannel network must assemble data from a wide range of internal and external sources. Using machine learning algorithms, a retailer can learn which factors most influence sales in every zip code and calculate actual and potential sales for each store and each local market. Inputs into a geospatial model would ideally include not just transaction and customer data, but also store-specific details such as store size, product mix, site-specific information such as foot traffic and retail intensity, environmental data, including local area demographics, and anonymized mobile phone location data. And of course, highlighting the anonymized mobile phone location data because that's where we play. And so we see that data as one piece of a much more sophisticated model. And our approach has been, we gather that data as the flower, and then we give it to the geospatial scientists who are the bakers who are going to create incredible things with that data. So where does that data come from? So we're talking about pre-processed anonymized mobile phone location data. So that data comes from typically from mobile apps. There's obviously a lot of kinds of location data. We work with GPS data that comes from the GPS chipset on a mobile device that's originated within a mobile app. In order for us to get that data, the user has to have consented and received disclosure about how that data will be used and agreed to have shared that data with our supply partners. So we gather that data together from thousands of sources. We validate that data as part of our transformation stage in our data pipeline. And then we deliver that data, typically billions of rows a day of GPS data that we refresh, typically S3 bucket to S3 bucket. And our goal is to go and get the data, clean it, and prepare it so that it's ready to go for analysis, so that our customers don't have to spend a lot of time messing around with sourcing and cleaning data. So I think might be helpful if I just cover what we see as the two most common data feeds for these types of analyses. The first is the rawest of location data. So we call this our movement data, and you'll see this in the market. We call this movement data, and it is essentially just a timestamp, an anonymized mobile device ID that represents it's a persistent ID that represents a single device, and then the latitude, longitude reading, and importantly, a horizontal accuracy. And so this is billions of daily rows of GPS observations. It is important when selecting this kind of feed to make sure that the source has aggregated enough underlying data sources so that that bias is reduced. So for example, some suppliers of this kind of data are tied to maybe one app or one SDK or some other source. And so it may be skewed in terms of the kinds of apps that are represented or the region or the kinds of device across Android and Apple. The benefit of using this kind of a raw feed is it's the most flexible for your model. And so because it's such a raw ingredient, you can really do all kinds of things with it without a lot of limitations on parameters. The downside of using this type of raw feed is, of course, it's very large data, and so higher storage cost, higher compute cost, longer processing time to kind of think about. The second kind of location data feed that we think is most common is a visits feed. And so this is, I'd call it process data. It's one step above the raw mobility data. It is going to be, if the raw mobility data is like flour, then this is going to be like cake mix. And so the goal here is to take the raw mobility data, match it with point of interest polygons, and then create a visit. So the output's going to be a timestamp and an anonymized mobile device ID, and then some sort of point of interest. And this is the process that we use to create visits. There's obviously many different ways to do this. We start out with the cleaned raw population movement data. We run it through a density-based clustering algorithm to identify suspected visits by cluster before we look at polygons. And then we overlay those clusters on high-quality points of interest. We use the SafeGraph polygons for this purpose, and we generate a list of suspected places, suspected visits, I should say. And then we run that list through a ranking algorithm to essentially pick a predicted winner for where that cluster occurred. So you kind of see that visually represented here. And then from that winner, that becomes one visit. So here's what the schema typically looks like for a visit. As you can tell, again, it's timestamp, anonymous ID, and then some sort of point of interest. The benefit to this kind of a feed is it's been pre-processed, and so a lot of the pre-work is done. It's much smaller data. It's millions of rows a day as opposed to billions, and so it's going to save a lot on compute and storage. The downside, of course, is it's not as flexible as the raw data. Obviously, you have to sort of trust the algorithm that generates these visits. So I just, to kind of wrap up, wanted to share 3 use case examples for this kind of data. The first is predicting long-term demand trends for autonomous vehicles. And so this was something that KPMG did, built on the raw movement data. And their goal was basically to look at what insights can you get from how people move through a city to predict the ways that autonomous vehicles, different types of autonomous vehicles might meet their needs. And so they started with just a lot of trip analysis, looking at how these trips were, how and when these trips were occurring, time of day, where the trips were going. Was this a commute? Was this some other kind of trip? From that, they were able to segment those trips into a number of different kind of consumer segments, and then from that generated ideas for types of autonomous vehicles. So that's the first example. Second example, this is a customer that we work with. It's a regional grocery store. They basically had a lot of rich data from their loyalty program, and so they were able to join that data with the anonymized raw movement data and some of the things that they're working on right now. So looking at the shopper journey pre and post grocery store visit, what other retail locations did the shopper visit before? Where did they go? Did they go after? Was the grocery store the first choice or the second choice over time? Looking at local competitors and also complements, basically adding in a degree of customization into the loyalty program messaging, and then also starting to plan ahead for future store site selection. Last example I'll share, so very common use case for this data is location contextual advertising and measurement. And so we've got a lot of customers that are doing this kind of work with the data, typically joining the data with anonymized demographic and other, and perhaps transaction data to do offline measurement of online advertising, generating sort of like non-obvious insights about customers and about consumers and crafting targeted ads based on those. And then also matching across mediums, so out-of-home exposures, connected TV exposures, and then matching that with offline behavior. So just a few examples from Veraset customers. So I would just say, in summary, we think we're super excited about this data. Raw location data is super useful for modeling, generating insights, certainly all across retail, CPG, and other kind of product marketing use cases. We see the most popular formats as the raw movement and then the slightly processed visits feed format. And we see every day just all kinds of awesome things that geospatial data scientists are doing with this data. So I think with that, just a few questions. And let me just see, I'm not sure if I can find here if we have any. So let me just take a look here.
Hi, Parker. Just gonna come in with a question here. You're talking about the geospatial data scientist. Something that I think a lot of us have seen, there's actually not always that many who perhaps have that as their job title yet. Sometimes it's a GIS person who's really starting to upskill in data science, or it's the other way around. It's somebody who's a data scientist who's starting to do their first things with spatial data. What's your experience? Are you typically working with more GIS people or more data science people?
Yeah, so I guess I was using that term in the broadest sense possible. I mean, to us, anybody that's working with geospatial data and applying data science techniques, that's kind of who I was referring to. So not an official job title or anything like that. Because we work with folks in so many different industries, I think the job titles are about as varied as the industries that we work in. For our hedge fund customers, they're probably just going to be called an analyst of some kind, or just a data scientist. But I think we certainly are seeing this geospatial data become widely adopted by folks who are not from traditional GIS or other types of backgrounds.
Absolutely. We have a question in the Q&A here on Hopin. Bertrand from Rakuten says, do you have an approximate of how many UUID raw data in the US? How about other countries? What does the data delivery look like in terms of frequency? And he said, awesome presentation.
Yeah, great. Yeah, thank you. So our goal is to have a representative sample of the population in the countries for which we see this data. In the US, we typically see somewhere between 30 and 40 million daily active devices. And on a monthly basis, that's much higher, typically above 100 million or so. Outside the US, the data is not as dense, just kind of depends on the country. But we're seeing somewhere between 40 and 50 million devices outside of the US. We don't currently have data in the EU, and some regions of the world are harder to see data. China, for example, not a lot available there. And then I think as far as data delivery, we update once a day. And so that's typically, because of the size of the data, that's typically just an S3 to S3 bucket delivery, refresh daily.
Fantastic. And the follow-up question also from Bertrand is around the pricing model. Is it one-time purchases, licensed, per month? What does it look like?
Yeah, so our typical setup is going to be an annual subscription to a country. And so our customers will choose which countries they're interested in, and we set up essentially a Firehose feed for that country, again, refreshed daily. We have some other creative structures with more platform partners as well, but typically it's kind of a fixed rate for a country for the year.
Brilliant. Fantastic. Well, Bertrand, if you want to follow up with Parker, I'm sure you can do so on the chat afterwards or reaching out directly on the platform. But Parker, thank you so much for joining us. It's been great to hear.